Today is just a quick overview of some of our exponential and logarithmic properties and how we can use these properties to rewrite or solve logarithmic equations. To begin this lesson, I want to start off by a simple property that deals with a base and a power. If you are given an equation that has a variable in the exponent, one of the ways that you can solve this equation is by making the bases the same. So if our base numbers can be rewritten so that they are a base to a power, and the bases become the same, then the powers are going to be equal to each other. So let's think, is there a way that I could rewrite 16 as a number raised to a power? You may have said 4 squared, and that's correct. When you put the 2 as an exponent, you do have to multiply it times the current exponent, negative b. Let's do the same thing for 64. Can I rewrite it as 4 to a power? Yes, 4 cubed. So as long as your base numbers are the same, then your exponents are now equal to each other. Let's go ahead and clean up the exponent on the left. 2 times negative b is negative 2b, and this will be equal to 3. To solve, since negative 2 and b are multiplied, I'll divide both sides by negative 2. So b is equal to negative 3/2. Let's do this one more time, just so you can see another example that includes a fraction. We're going to use the same method. If I can get my base numbers to be exactly the same, then the exponents can be set equal to each other. When you have a fraction, you do want to bring this denominator number to the top. One of the ways we can do that is by using a negative exponent, negative 1. So if I rewrite this as 5 to the negative 1 power, that is equivalent to 1/2. This negative 1 is going to need to multiply with the negative 3x that was already up there. Can I rewrite 625 as 5 to a power? Yes, 5 to the 4th. Now that you have the same base, you no longer need this base. You can set the exponents equal to each other. Negative 1 times negative 3x is 3x, and we'll set that equal to 4. To solve, we'll divide both sides by 3. So x is equal to 4/3. Now we're going to get into some of our properties of logarithms. In this example, they simply asked me to rewrite this equation, which happens to be in exponential form, in logarithmic form. So first, let me show you the difference between the two. Logarithmic form will have a log with a base, a number, and it will be set equal to a power. We can use a loop method to change it to exponential form. The base raised to this power will be equal to this number. They have given me this equation in exponential form. So they want me to write it in logarithmic. The first thing I need to do is identify my base. The base is 16. As you can see here, the power is what is going to be set equal to. This has a power of 2. The 256 will come here, and that is our answer, our number. 16 squared is equal to 256. Let's do one more with a fraction, just so you can see it one more time. I'm given the equation in exponential form. They want me to write it in logarithmic. The first thing I need to do is identify the base number, which is 361, and I will write it here in the base, the basement. The power is going to go to the opposite side of the equal sign, and the 1/19 will come here. In these next two examples, we are given an equation in logarithmic form, and they want me to change it to exponential. Just like I showed you previously, I think the easiest way to do this is to use the loop. A base of 7 raised to the second power will be equal to 49. 7 squared equals 49. Let's do this one more time just to make sure you got the hang of it. All we're doing is rewriting. We don't have to do any solving at this point. A base of 3 raised to the negative 5 power will be equal to 1 over 243. 3 to the negative 5th equals 1 over 243. Now we're asked to evaluate an expression that is written in logarithmic form. We can use some of these past properties that we had learned, like the loop. 7 raised to a power will have to equal 49. So what power can I raise 7 to? If you're unsure, think about it similar to the first examples that I gave you. If I can change both of these into the same base, I'll automatically know what that answer is. Can I express 49 as 7 to a power? Yes, 7 squared. So my answer is 2. Let's do it one more time just to make sure you've got the hang of it. 6 raised to what power will equal 216? Again, if you need to write it out just so that you can see what's going on, do that. Can I change 216 into 6 to a power? Yes, 6 cubed. So the answer to my problem is 3. In these next two problems, you're going to notice that if we ask the question, 6 to what power equals 15, we don't have an answer. There isn't a power that will result in 15. So in a case like this, we have to use a different method. And this is another property of logarithms. We're going to use what we call change a base. And change a base allows us to solve logarithms that are going to give us decimal answers. We're going to take the log of this number and divide it by the log of the base. So log of 15 divided by log of 6. The problem asks us to approximate each to the nearest thousandth. When you get out your calculator, since this is set up in a fraction form, you can do alpha y equals enter to also enter it into your calculator in fraction form. Log of 15, we'll close that parentheses, divided by log of 6. So my answer is 1.511. Here it is one more time. If I ask the question, 3 to what power will give me 6.8? There isn't a power. So I'm going to use change a base to solve this. If I take log of 6.8 and I divide it by log of 3, and we'll get my answer. I need to round my answer to the nearest thousandth. Alpha y equals enter will give me that fraction bar, log 6.8 divided by log 3. 1.745. There's another property of logarithms that expresses a relationship between addition and multiplication and subtraction with division. If you have two logarithms with the same base, you can combine them into a single expression. You just need to pay attention to whether or not these two logarithms are being added or subtracted. If they are being added, you're going to change this into a multiplication problem. So what are you going to multiply? You're going to multiply these numbers. 10 times 11 gives me 110. Here is an example of a subtraction problem. As long as the log and the base is the same, then I can combine these into a single expression. If it is subtraction, I'm going to use division. So what do I divide? These numbers. Now the order is very important. We'll start off by writing our log base 2. You're going to divide the first number by the second number. If it actually divides, do that, or if it reduces, do that also. If not, this will be your final answer. In these last couple examples, I'm going to show you some logarithms that look like they might be complicated, but if you apply some of these previous properties, you can simplify them and solve nicely. In this case, I have a basic logarithm. It is not equal to anything, but you can still ask the question, 2 to what power would equal 2 cubed? If you need to write it out so you can see it, you can do the loop. 2 raised to this power is going to be equal to this number. Sometimes writing it out makes it very obvious. The answer is 3. It's going to be the same in this problem, even though there's a variable there. If I ask the question, 7 to what power is equal to 7 raised to the power of x plus 2, I know the answer is x plus 2. This problem also could look complicated at first glance, but if you think about those properties, you can simplify it without much effort. Here, I just have an exponential. I have a base, and it is raised to a power. I just don't know what the answer is yet. I can change this into a logarithmic problem, and when I do that change, the answer becomes obvious. If I rewrite it, and I take the base and put it in the basement, and remember, the power comes to this side, and the number comes here. Now I can compare. If I have a log base 9 equal to a log base 9, then these numbers have to be equal also. So the answer here is just simply 2. One last example, just to show you how we can apply some of those previous properties. Again, I know that 2 raised to a power is going to equal 8 cubed. If I rewrite this as 2 raised to the power equals 8 cubed, I then realize I need to get my base numbers to be the same. So can I express 8 as 2 to a power? Yes, 2 cubed. Don't forget, you have to multiply these two numbers together. So 2 to what power equals 2 to the ninth? The ninth.